We'll have a look at a bilging problem here where we have a box-shaped vessel, even keel, saltwater, length, breadth and draft, with a midship compartment, length 16 metres, extending the full breadth, and from the watertight tank top to the freeboard deck, so from the tank top to the deck, has a permeability of 0.65, the compartment, and the height of the watertight tank top is 1.8. So we've got 1.8 here, then we've got the compartment that's bilged here from that 1.8 up to the draft mark. Now, always important to draw a sketch. So overall length 120, 16, 1.8, 5 metre draft, 22 metres. First thing you need to be aware of, or not forget, is the permeability situation. So the compartment gets bilged, so we need to calculate. Let's look at the final draft first. So to get the final draft, it's simply get the sinkage, add that to your initial draft, and then that's your final draft. To get the sinkage, it's the volume of lost buoyancy over the area of intact water plane. Now the volume of lost buoyancy, if we look here, it's not the length of 16 metres. Because we've got a permeability of 0.65, the effective length of the compartment is 16 times 0.65, 10.4. So it's 10.4 by the breadth, by the depth. So remember, because you've got this tank top of 1.8, this is actually the depth, 5 minus 1.8. And the area of intact water plane, do not forget as well, it's 120 minus 10.4, not 120 minus 16, 10.4, because of the permeability, times 22, which gives you the area. 0.304, so our final draft is 5 plus 0.304, 5.304. Okay, so sinkage, lost buoyancy over intact water plane, 5.304. Then we're asked for the final GM. Well, we're not given any kgs, because normally, GM is km minus kg. But what we do know is the kg, the centre of gravity of the vessel, isn't going to change. So if we can find the km of the vessel initially before being bilged, and we can find the final km after being bilged, take one from the other, and that's the actual change in GM. It can also tell us whether it's reduced or increased. So to get the initial km, it's kb plus bm. Well, kb is simply the draft divided by 2, and bm, because there's no situation occurred, no bilging or anything, it's just simply lb cubed over 12v, b squared over 12d. We can work out our kb, our bm, add the two together. So initially our km is 10.567, half the draft there, and lb cubed over 12v there. So straight away we can find our initial km. That's pretty straightforward. If we can find our final km, then compare the two, and that will give us the change in the GM. The problem here that we're facing is the kb, because of this situation that we've got the tank top, and because of that we have to work out the moments situation to get our new kb. Let's just skip that for now and look at the final bm. And the final bm, you'll notice on this one it's lb cubed over 12v, 120 by 22 for the initial one. Well, here it's 120 minus 10.4 times 22, 22, 22. Okay, so because of the compartment being bilged and the permeability, the length is actually 10.4, so it's 120 minus 10.4 for the length now after bilging. So that's how we get the final bm. The kb, well, we've got a volume of 120 by 22 times the new draft, 5.304. So 120 by 22 times 5.304 multiplied by half the kb will give us these moments, and then we have to subtract from that the bilged compartment. Now the bilged compartment will be 10.4, obviously the length, breadth of 22, and the depth is going to be 5.304 minus the 1.8. So the new draft is 5.304. We must subtract the 1.8 from that to get this bilged value, the volume. So length, breadth, and then the actual depth. Then we need to get the distance from the keel to its centre of the buoyancy. So we've got to add the whole of the 1.8 and then half of this value here. So it's 1.8 plus this whole value, 5.304 minus 1.8 over 2, which gives you 3.552. Multiply that by the volume, and that gives you the moments there. So we get the final KB will be the total moments divided by the volume, total volume, and will give us a final KB of 2.597. Once we've got that, we add it to the BM, and then we can make the comparison between the two KMs, and we can see that the change of GM is going to be 0.602, a reduction. So this situation here is creates a bit of a problem because of the tank top here. The KB isn't simply half the draft, it cannot be half the draft. We have to take into account the fact that we've got this, if you like, this space here that hasn't been bilged, and we've just got that area there that's been bilged, that's below, if you like, below the water line.